Thank you, Irina, for the great introduction. Okay, one moment, I'm sharing the screen. Second monitor. Yeah, as I said, thank you for the great introduction, and let me thank by first all the audience for coming here. I'm very pleased to have you all here. I'm very happy that you are interested in the platform, and I hope that it will be an entertaining session. Let me also thank the FIO and the AIMS group in particular, and Irina and Karna for hosting this webinar and for supporting me during the presentation. Okay, I see that I see a lot of names that I know in this webinar, but also there is a consistent part of the audience that I never met before. So I will give probably boring for those people who already know VocBench. I will give a very short introduction about who I am, what I do, and besides, I mean, what was already introduced by Irina, and how VocBench was born, and then I will add some slides about VocBench3, but not too many because I want to go directly to show you a preview of the platform. I anticipate that you will see in the next slides that the platform is still under development, even though we are very close to the release that is foreseen for this summer. And so, okay, this is probably not the very latest version that you will see out when it will become publicly available, but it will give you a very clear idea of what you will see in the next weeks. So just a few words about where I am, what I do. I'm Italian with a touch of Greek blood, and I'm living in Rome, where the city where I'm born, and I'm working at the University of Tor Vergata. Tor Vergata is realized as a university campus. It is distributed in a wide area in the southeast part of Rome. Here you have a satellite view of the area where I work. That is the Faculty of Engineering. And I'm part of the, as you see here, ART group, the Artificial Research Intelligence Research Group at Tor Vergata. My group is of, let's say, average size, actually quite big for the average Italian size of a research group. We have a full professor, Maria Teresa Pazienza, and then 2 associate professors, and me as a researcher. For those who know me quite well, okay, I'm thinking about the air, but I'm honest, I'm just very lazy about changing pictures, but I promise that I will do. There are quite too many airs there. There are various areas of interest in the group. The group was born as a natural language processing group, and this is still one of the main interests for the group. There are people working directly on that area, working on machine learning, and then there are those black sheeps working on knowledge engineering that you can see in the last part of this slide. We have a quite wide technology asset that has been the outcome of a few research projects and other kind of activities that have been carried on in this year. Our flagship platform is VocBench. Actually, that has been it's a marriage with a platform that we developed 10 years ago now. Yeah, time passes, and it's a platform for knowledge management, for collaborative knowledge management. And then we have other applications that we as a group that started with natural language processing. Obviously, even those working in knowledge representation have a kind of touch for language, for lexicons, and so on. In particular, two members of the group working on VocBench are also part of the VB3 community group that developed recently the ontologies model for interfacing lexicons and ontology, and actually for representing lexicons. So we have produced systems for producing terminologies and lexicons, and for semi-automatically enriching conceptual knowledge with lexical content. And information extraction obviously is where natural language processing and knowledge representation find a common ground. We have a platform that is also actually part of VocBench, the new version of VocBench, that is for knowledge extraction from any kind of unstructured information. It is an extension of the popular Apache UEMA framework, and it allows to extract information from any kind of source and to produce triplified data. So a few words about VocBench, at least the ancestors of the platform that I'm presenting it today. The platform was born inside FIO. It was born actually with a different name. It was called AGROVOC Concept Server. And why was it built? It was built to manage AGROVOC, as the name suggests. At that time, I'm talking about 2009, I think, they had this big thesaurus that was going to be digitalized. There were already a version on a database, but the visionary head of the AIMS group decided to embrace this new trend of the open data, of the linked open data. That name was not that popular. At that time we only spoke in terms of semantic web. And they had this AGROVOC that contained more than 32,000 concepts. And at that time, it was already available in 22 languages. Today, there are more or less 25. And they had a global group of terminologies that were widespread all over the world. And there was no tool to support their work. Or at least not that could support the needs that the specific needs that they had. So in the context of the NEON project, that was a big research project led by the European Union, they developed a platform for maintaining AGROVOC, a collaborative platform, so that different users from all over the world could contribute to the development of AGROVOC. Obviously, over an iterative workflow and a process that could allow terms to be validated, checked, and so on, before they could finally find their way to the final publication. The system was exploiting the protégé, but actually in a customized model and customized system for dealing with thesauri. This is a screenshot of the first VocBench developed released in 2010. I had the pleasure to participate to this project as a consultant for FIO. In the latest part of the system, I contributed to performance optimization, because dealing with such big thesauri and moreover with a lot of lexicalization requires some effort, and also it's not trivial, especially for technologies with RDF that at that time were not quite mature. So there were some issues, some limitations, obviously mostly dictated also by the time. At that time there was, for example, no support for emerging standards like SKOS, so they had to invent a model for the representing thesauri. So we had a very, very tight schedule. We decided that the system very soon met the enthusiasm of other groups inside FIO and other organizations outside FIO. So we decided to release in a very short time span a new version of VocBench that actually Johannes Kaiser coined the name VocBench as a replacement for AGROVOC Concept Server, as a system tool for managing any kind of vocabulary without being tied to the FIO domain, to the domain of agriculture. So we embraced the SKOS and SKOS-XL standard that were at that time recommended by VB3 for representing thesauri. And with such a tight schedule, because there was a lot of demand, we adopted this solution. We had a platform that met many of the requirements of VocBench. That was a general purpose knowledge management platform for RDF. and covered also SKOS and SKOS-XL. So we decided to make, well, sometimes we joke, I would say the marriage, but at that time we call it the Frankenstein, because we just rewired the two systems together, maintaining all of the interface that the people were already proficient with, and replacing the backend with this Semantic Turkey. We had a few requirements. Multilingualism by first. Obviously, as I said, it is a platform that requires requires contribution from all over the world. This means that it has to enable editing in different languages, and also possibly to provide an interface that is available in different languages. Controller collaboration is important because, yeah, crowdsourcing is useful, but if you want to have an authoritative resource, you need someone to validate every step that is done until it goes to the final publication. Data interoperability and consistency. This is a must for an open data set. You need to produce a resource which can be aligned, that can be processed by other systems, that can be accessed on the web, and it must be consistent. That is, there should be no violation of logical, or logical constraints. Software interoperability as well. It's important for a software system that foresees possibly new extensions, also for dealing with progressively new functionalities. Scalability. This means both data scalability and, in a sense, also development scalability. We would call, as a software engineer, we would call maintainability. That is the capability for a software to be updated and to be improved without requiring big changes in the software to be done. Under the hood, data access and modification, the system has to be, and this is also the next requirement, has to be easy to use for users and administrators. But at the same time, we should have, let's say, those data geeks able to access the system and change the things very easily, even bypassing interfaces, user interfaces, and other things which are normally appreciated by terminologies, for example. So here we came out with VocBench2. As I said, the interface was very similar to the original one. We actually, it was based on the same technology, but what we had is another set of functionalities like support for Sparkle, the introduction for scheme management, and well, you can see from the very long list of tabs here, improved editing capability. This was the team that developed VocBench2. On the left, you are the developers. As you may see, most of the group comes from my university. There is me, and then there is Andrea Turbati, Manuel Fiorelli, and Tiziano Lorenzetti, which are research associates and assistants working doing research with me and working on the platform. And then there was Sashit Rajbandari. Sashit Rajbandari, in a sense, is the father of VocBench. He worked on the first edition of the platform and joined us for the development of this new version of the system. On the right-hand side, you may see just a part of the team that worked, the core team from FIO that worked as users in the development of VocBench. They were helped us with requirements, with tests, and so on. There were those bringing us to reality and tell us that we shouldn't think too much about super architecture, but about the final users. And I really must say that after this experience, I appreciated the presence of users, testers, and this kind of things even more than I should normally acknowledge. Okay, here I have a few slides about how these things have been implemented in VocBench, the requirements, so multilingualism and on. But I would keep these slides in the presentation because I will give them to you after the webinar. But now I don't want to stay too much on VocBench2, and I would like to move quicker to VocBench3 and also to give you a demo. Moment, I will move to, so I will skip some of the features that are but now available there. You will already see them during the demo. So just a few words about the architecture in VocBench2. It was mainly a three-tier architecture. We had a presentation layer. In this case, it was in the Google Web Toolkit user interface, and it had also a web application that was, as I said, it was rewired to our backend, that is Semantic Turkey, the RDF management system that I mentioned before. It is important to mention that the architecture was extensible. The Google Web Toolkit really didn't support extensibility that much, but we managed to leave extension points for new functionalities at the level of the service and the data implementation, such as, for example, the possibility to use different triple stores. So this is a more conceptual view of the architecture. We have the front end that mainly with Google technology for visualization. In the middleware, actually, the middleware is cut into two parts. One part is the web application that is providing the client of VocBench, and one other part is Semantic Turkey, the RDF management framework that, as you say, was connected to VocBench. And then in the back end, there were two technologies. One is the triple store that was used only for the data, for the RDF data, for the content that you were editing the data set. And then there was a database, a traditional relational database that was used for user management and history and logging and many other things. Well, this is partially another project, but partially became a sort of companion to VocBench. VocBench is a web application. It's a collaborative web application. This is great, but sometimes people ask us, if I just want to work alone, at least at the start, and I want to edit a thesaurus, should I go through all the installation steps of VocBench, which with the passing of time, we managed to make it quicker and easier. But in any case, people wanted just something in the area of click and go. So Semantic Turkey was the response to this need. Semantic Turkey was a Firefox-based interface for Semantic Turkey. It contained no user management, no authentication. It was just a simple editor. It could be used in a collaborative way, but there was actually no support for logging or for collaboration. Just multiple users could work on the same dataset. But it really managed to satisfy the need of people that wanted a very quick to use platform. Okay, these are some slides. Again, on this case, I prefer to keep them in order to provide more background to the audience. So you will find them in the slide when we release them. This is a comparison we made in 2015 when we published a paper about VocBench2 at the European Semantic Web Conference. And it compares VocBench with Poolparty, Thematres, SKOS-XLdevelopment, and Web Protégé. At the time, we didn't manage to have an evaluation license for top-grade AVN. And here you can see some of the top points of VocBench. Obviously, the fact that it's free to use, the support for SKOS and SKOS-XL, the possibility to manage scheme in an advanced way. As you may see here, some tools are not able to manage scheme at all, or some deal with scheme in a very simplified way. For example, only allowing top concepts to be reconducted to the scheme, which is actually contrary to a constraint. Here there is an example in the SKOS specification. The fact that if a SKOS concept belongs to a scheme, it does not entail that all of its broader narrower concepts belong to the same scheme. So in VocBench, we dealt more in detail with scheme management so that every concept can be specified as belonging to one or more schemes, and this can be specified for all the concepts in the thesauri. It had good support here. The winner is Poolparty for data quality, but it had VocBench had already a good support for metrics, and we were introducing also validation rules. And the workflow management was another strong part of VocBench with respect to the competitors. This is some reports that is available also online about user community and the evaluation that has been given to the platform. And also everything is reported in the paper, and some links to VocBench and to the mailing list and to the site on the AIMS website. So we had a few limitations. By first, as I said, we joked about it, but it was true. VocBench2 was a sort of Frankenstein. We put VocBench1 with all its already tested and very known interface together with Semantic Turkey. The point is the potential of Semantic Turkey was much higher. While VocBench, it is true that the user interface was very known by user and was very user-friendly, but at the same time, it had some limitations, and in general, all the lattice, the knowledge lattice of VocBench2 was not talked that much for scalability. And this is not a fault of anybody, but it's just something inherited from the first version. It was talked for a specific vocabulary, it was not meant to be extensible, to be open to a community, and so on. So this is something that we inherited because we are trying to deliver a new version of the system quite easily, but still there was the hunger to produce something more. And so we came to VocBench3. VocBench3 aims to be a web-based, multilingual, so all things that you already know, collaborative from VocBench2 development platform, but in this case we are not addressing only thesauri. Even though thesauri will remain the strong point of VocBench, we are starting to address also owl ontology. Also SKOS and SKOS-XL. In VocBench, the default was SKOS-XL. It was possible to export thesauri in the SKOS core standard. In VocBench, simply we detached the vocabulary that is using for knowledge management and the vocabulary that is being used for the lexicalization. So what you can do is to work on an owl ontology or a SKOS thesaurus, and then you can decide which kind of lexicalization you will use. You will use trivially RDFS labels, you can use SKOS terminological properties, or SKOS-XL reified labels. So you decide this at the start of the project, and then you will work exactly with the knowledge and lexicalization model that you wanted for your system. This new version of VocBench is funded by the European Commission ISA² program. Its development is managed by the Publication Office of the EU under Contract 1063/EU awarded to Infeurope, the company Infeurope. The final delivery of the project is by the end of July 2017. This is the VocBench3 team. This is more or less the same team as before for what concerns the developers. It's again the group into Vergata. Concerning the users, well, in the meanwhile, the VocBench community has increased a lot. We have by first, obviously, how not to mention the Publication Office of the EU. But we have actually VocBench is now the result of the contribution and the feedback of the many users that have been adopting VocBench2 that are, I hope, eager to move to VocBench3. Sorry. Here I put just some of the logos of the organizations and users that are adopting VocBench. Sorry for any omission. Obviously, there should be many more. So just let's give a look at VocBench3 in terms of the differences with respect to VocBench2. By first, the presentation. First, it was in the first and second version, it was the Google Web Toolkit. We moved to the new framework again from Google, Angular. It was previously known as Angular 2. Just for terminological clarification, the first version of Angular is now called AngularJS, while the new version was previously called Angular 2, but then they started to adopt semantic versioning. So actually Angular 2 has already become 3, 4, 5, I don't know which version they reached now, but the new framework is simply called Angular. Also, previously we had a business logic that was driven again by the web application of VocBench, and then there was Semantic Turkey only for dealing with the RDF aspects. Now, actually, Semantic Turkey, let's say, has become Semantic Turkey on steroids. Semantic Turkey will take care of everything: user management, authentication, data validation, history, everything. And actually, the VocBench presentation layer will remain just what it is, a presentation layer. There is no business logic in the interface now of VocBench. Then also we had Aulart API was a library that we developed in order to cover different kind of middlewares, but we decided at a certain time to take a stance. We decided to replace the Aulart API with a specific middleware, specifically the Sesame framework that is now called RDF4J and has moved under the Eclipse umbrella. Simply, we realized that maintaining a natural middleware such as Aulart was no more cost effective. And we decided to embrace this middleware that actually we could say that today no relevant triple stall is not compatible with RDF4J. And still it is possible to connect to different triple store which are compliant with RDF4J. There are some constraints, we'll talk about them later. Specifically, if you want to use all of the functionalities of VocBench, all the features, like for example, history and validation, you need to use a triple store which is compliant also with the sales stack mechanism of RDF4J. This is because we also developed some extensions that need to be deployed on the triple store in order to enable these advanced functionalities. Why this? Because we are aiming to simplify in a sense. Actually, there is a lot of, the new architecture is quite intricate, but in terms of different components, we have simplified a lot. We remove all these different technologies from the front end and we used only Angular as a static web application, single page application. We removed everything that was related to the relational DB. VocBench3 is completely based on RDF. Everything that is stored in VocBench is stored either as RDF data or it has a file-based support framework. But in any case, even the file-based, the information stored in files is serialized by the application in RDF. So for example, every user has a URI assigned to him, and every information that is processed by VocBench, when referring to that user, refers to the URI of that user and uses standard ontologies such as the provenance ontology for referring to the actions which are taken, to the user who took that actions, and so on. So this is a simplified and again perspective on the architecture. We have Angular 2, we have Semantic Turkey that now takes care of everything, and we have the backend. The backend is only a triple store, and then we will plan maybe to provide different data serialization for aspects such as user management. At the moment, everything is based on a file system. We have a new range of requirements. These one are the first 7 that I described. Now, RDF language support. I already made it clear that VocBench will cover all SKOS. And for concerning the lexicalization, it will work on RDFS label, SKOS core, and SKOS-XL, and maybe in the future even adopt more advanced lexicalization mechanisms, such as, for example, Lemon, that is gaining more and more hype in these latest months. Maintainability. This is a very important point for VocBench 3. VocBench2 adding new services was not that easy. This is because there were a lot of dependencies from the service and other information that was stored in the complex knowledge model of VocBench2 that were related to, for example, who could access a service, which are the outcome of the service, and which are the prerequisites for a service in order to be able to run it, and so on. In VocBench3, we adopted a different system. Everything is declarative. Everything is inside the service, so the developer that writes a new service has the possibility to specify everything in the code in a very clear and succinct way, and then everything is managed by the framework. There is no need to take care of introducing the new service and somehow making it interact with the rest of the platform. Having full editing capabilities. In this sense, I take this concept from theory of system, that is observability and reachability. Any triple that is present in the triple store should be visible somewhere, somehow, and be able to change it, modify it. We should have a very convenient user interface for changing anything in VocBench, but at the same time, we should be able to change the things at the very lowest level. Provenance, as I said before, it's important. We have to take care of to take note of which users change anything, of which are the actions which have been performed, and provide this information according to standard vocabulary. Versioning support. It is possible to store, let's say, snapshots of a dataset and to review them later in order to compare them with the current version. Metadata descriptions. So now there are a lot of metadata vocabularies that are being used to really power the idea of a really automated linking of data. Vocabularies such as void, the vocabulary of interlinking datasets, lime, the lexical metadata vocabulary, dcat, and the specific asset for public administration, dcat AP. And so on. So VocBench allows to specify the metadata for every dataset that is managed through it and to export it. Customizable user interface. We will see more. It's easier to be seen than to be said. So we will see it later during the demo. And as I said before, everything must be in RDF. There should be no other models, no relational DB, nor anything. Everything is natively stored in RDF. This is the new architecture. In a sense, it's very similar to the one before. As I said, here we have a new data layer that is natively based on RDF4J, but still allows to connect to different triple store. And we have incremented the extensibility. We have already quite a few extension points, for example, for metadata generation, for RDF resource. So it's possible dynamically to add new exporters for new metadata vocabulary. RDF resource rendering, the rendering of resources is already partially configurable, but if some users or some organizations have specific needs, they can write their own component for rendering the resources and plug it to VocBench. URI generation also is important in order to comply with the specific in-house requirements of every organization. So it is possible to write, if the URI generation component that is embedded in VocBench is configurable, but again, it is possible to rewrite one from scratch and to use very specific editing capabilities. So, as I said about extensibility, there are APIs that are available both in Java and in JavaScript for invoking the services. We plan to develop a reusable RDF widget library. But for now, for the developers working on VocBench, the system is already quite based on components. And then concerning the services and the data model, everything is based on HostGI, the Open Service Gateway. So plugins can be added for existing extension points, as I say, the export filters, rendering engines, repository configuration, URI generation. This is something, okay, for the developers that are among the audience. We also make I anticipated this a few slides before. The development of service is more compact and is more declarative. We added a whole set of annotations that can be added to the code and that are processed at runtime. This means that there are a lot of business logic which does not need to be specifically written by the developer, but is automatically managed by the framework. Okay, and this is just a look where we would like to go in the future. The idea is that this was something that we realized together with FIO, taking a use case that they had the population of some properties in AGROVOC that existed in the model but they were not available in the data, like is pest of, as pest to tell which insects predate which plants and which insecticides can defend those plants from the predators. And this is an example of it is possible to extract information from text, get suggestions, and populate. This is maybe the future of VocBench. For now, we have decided to go back from the root and focus much more on all the standards that are available for linked open data to meet all the state of the art about this. But in the future, we might make this thing become less an experiment and more something that is core technology available in VocBench. So it's time for a demo because maybe I've already talked too much. Okay, as I said, this is not the final platform. Be prepared to face some bug. This is really something that has been built yesterday, and but let's appreciate the enthusiasm of the very latest build. Okay, so as a first thing, we could, for example, create a project for an ontology. As I said, VocBench allows to create an ontology other than thesaurus. We create, this is the section for creating a project. I'm creating an extension of FOF. So here I provide a URI for the ontology, a name for the project. The models, as I say, the model and the lexicalization has been divided. So here I can choose among OWL or SKOS. For me, it's fine OWL here. And I'm fine with RDF as label. I just want to create an ontology. History and validation, we will deal with them later. And everything here can be left as it is. I just have, okay, some words about these options. Here I can decide if to create a local repository, so everything will be managed internally by VocBench. To create a remote repository, differently from VocBench2, it is possible now not only to access a remote repository, but directly from VocBench, create the repositories in there. So I access an existing up and running, but I can deal with the creation of the required repositories directly from VocBench. There is no need to prepare them in the remote repository. And the other possibility is to access existing remote repositories already available in a remote triple store. So for now, we just create a local repository. Here you have the different configurations. As you may see, the last one is for accessing GraphDB. GraphDB is probably the triple store that is most compliant with the RDF4J interfaces, and it's also implementing the sales stack mechanism of RDF4J that allows developers to add simply new layers directly in the triple store that, for example, can be notified of other triples and take some actions for them. We use this feature for enabling history and validation. Also, GraphDB is a very performant triple store and has support for reasoning in subfamilies of the OWL language. So for now, let's just create a simple repository internal to VocBench. Here there is the configuration. The configuration depends on the kind of store that is being created. For example, this is the configuration for GraphDB, and this is for different kind of store that can be created. So now I will use a native store. A native store is something that is stored into to the mass memory of the computer that you're using, and it's persisted every moment. And there are some configuration options. For now, I will use no reasoning, and we'll make something very simple. So, as I said, I wanted to create an extension of FOF. Oh, sorry, I have to change the project in the meanwhile. This was my FOF experiment, if I'm not wrong. We'll move to this concept, and as a first thing, I will import the obviously the FOF ontology. Okay, so there is no FOF here. So from web, this is the URI of FOF. As you can see here, you can also input an alternative URL. This is for those cases in which the ontology has a base URI, but for some reason is still not available on that URI, or maybe you want to download a different version of that ontology and so on. So I will import the ontology. The ontology has been imported. I go back to the data, and as you can see here, I see the classes of the ontology. I can then start to model my own ontology. For example, I can create a subclass of fourth person and create, for example, an academic. This is a person working in some research organization. Sorry for this thing, it's not expanded at the moment. We will change this thing very soon. And for example, I can create a subclass of research organization and call a research organization. As you can see, the color of the classes is different. Why? Because the dark, I mean the icon in full color are the icons of the classes that I created inside my working data, let's say, while the data that is available because it has been imported or that been, for example, inferred, is represented in a lighter color. So you can immediately recognize what is the data that is belonging to your specific data set, ontology, thesaurus, whatever, and the data that's been imported. Obviously, this is also clear from the intuitively, it is clear from the prefix. All the fourth prefix of the information come from fourth ontology, but this is not completely ensuring this. The information actually that comes telling us that should be dark and this should be grayed out comes from the graph where we store this information. We have a URI that is associated to the graph of the ontology that we are developing, and only in that graph resides the information that is being managed by the user. So you can also add the subclasses, all the information here. One point about this view. The view on the right, we call it the resource view. The resource view is something very different from VocBench2. From here, yes, I read it. Thank you. I can expand a little. Is it okay now? Okay, I go along in the meanwhile while I read the answer. So another thing that can be done, for example, is as of complex ontology management, we can add another class, for example, as a superclass of the class that we are editing. But another thing that we can do is to build a logical expression. For example, we might say that all academic work for some research organization. So we could, for example, say that there is a property, I think, fourth member. And then this expression tells that they have a restriction in the sense that all academic are a subclass of all those individuals in the world that on the property fourth member have some research organization. Obviously, this has been validated because the elements that they put here, like fourth member and research organization, exist in the ontology. For example, if you look for member, you see there is this member here. Sorry, we'll attach here you can see on this and this, bottom the class and property view, you have this button. This enables the rendering. Usually I deactivate the rendering when I'm dealing with all classes and properties, but the rendering is usually very much functional and useful when you are dealing with thesaurus, because usually in thesauri people use unreadable URIs for the concepts and then decorate them with lexicalization. While in the use of ontologies, people prefer to really know which is the property that is being used independently of its lexicalization. So usually meaningful URIs are being used. So I deactivate the rendering here. And so I say this property is existing in the ontology, this class also. So it was possible to define this logical expression telling that every academic work for some research organization. Every expression here is clickable. So I can click here and I can see that this is the description of the element that has been created here. In particular, this is a restriction. And then the properties which realize that logical restriction are all some values from the research organization. And again, you can see here the member, the fourth member property. When I hover with the mouse, I can see exactly where this property is coming from. This is fourth. What else to say? About the browsing the system. Here you have some preferences. For example, one thing we had some comments from which are absolutely proper from the publication office that the flags are not really properly reflecting a language, because the flag reflects a country, not a language. So my answer was, yeah, absolutely, you're right, but at the same time the flags are cool. So we simply decided to go for both. You can decide to show flags or simply show the code for the language that is being used. So for example, in this case there are labels without any language, but for example, if I add a new lexicalization, this is research organization. Yeah, as you can see here, I removed the flag and I can see just the representation EN for English. Other thing that can be set to the preferences, this is very useful. The panel that you have seen before, it's a splitted panel. It means that whenever I change, I always change the main resource view here. If I click on another resource, I open in parallel another panel on the right. This is very useful when you want to jump to something without losing the focus on the main concept. The other possibility is to have a tabbed panel. In this case, you can have an history of visited resources. As you have seen, we have here that I click on these resources, I produce new tabs here. And then I can move along these tabs instead of looking for them on the tree. We have a search panel, as I showed you before, but obviously in some cases you just want to have here in a short list all the recent things that you have seen. And you can always clean them out all together by clicking on the last X. Obviously, I can create instances, so you can even just reuse an existing ontology and create new instance. Here, for example, I can create a new academic research organization. For example, I can create here University of Tor Vergata. You have here the one telling that there is one instance on this resource, and here I can create, for example, Armando Stellato. And then I can tell things like, I add the generic property. There is member. And then I can select the property I want, the class I want. Sorry, not here, but yeah, organization, research organization, University of Vergata. And this is just data entry on the system, nothing sensational. But the important thing is that through the resource view is very, very dynamic. Actually, the resource view is the same, always the same system that is being used for every resource. Every resource, even that has no type at all, you can always edit and change any detail in it. But as you can see, this form is not identical to this one. The point is, when a resource is being loaded in the resource view, the system detects its types and assigns them a role usually identified by the icon that you see here. So in this case, Armando Stellato is an individual, academic is a class. So class might have types themselves. Actually, every resource in RDF can have a type, even resources which are typed themselves. But then there are specific forms. For example, a class can have class axioms, while an individual doesn't have them. Here you may see DC terms created and DC terms modified. I didn't create them, but when you create a project, I will go back to the project creation, you have some optional settings. For example, so if you are not interested to metadata such as creation date, modification date, you can just tell not to use them, or you can even refine them by changing the property that can be used. There are some configuration that can be performed behind the system, and then the user, just when he creates a new project, they can decide to use different kind of property. There is a sparkle panel. It's even more powerful than the one you had in VocBench. It also allows to get prefixes from a service which is prefix.cc. So for example, here I want to add SKOS, and I get this suggestion. And for the rest is plain sparkle. Here you can perform any kind of query or update. Notice that in VocBench there is a complex authentication mechanism. So that every user can have some capabilities, and these capabilities are reflected then in the actions that they can perform. The sparkle panel automatically detects if the text here is a query or it is an update. This kind of detection is performed also by the client. So for example, now I'm logged in as an administrator in order to enable all the functionalities. But if I have limited functionalities, the Sparkle panel wouldn't appear at all. Or if I'm able to use Sparkle but not to write through Sparkle, then as soon as you write something, if that something is an update, the submit button will be grayed out. And for those that think that, okay, a smart user could just change the HTML code and force a query, obviously the server is down there to block you. Every computation that is performed client side is just performed in order to provide, to reflect at best what the user is able to do. But in any case, the server has the last word on what can be passed or not. So obviously this is an example with a simple ontology. Let's move to something quite heavy, EuroVoc. This is just the first loading. Okay, I took the biggest scheme in EuroVoc. As you can see here, there are a lot of, this was the heaviest part. There are a lot of root concepts. And then there is the possibility to select schemes. There are also a lot of schemes, but I selected the EuroVoc one, which is the scheme that contains all of the concepts. Please, Willem or Christine, correct me if I'm wrong. One advantage of VocBench3 is that you can select even more than one scheme, and simply the concepts that will be shown in the concept tree are the just one moment. Yeah, they were making me note that we are short on time. If you all agree, I could close by 4, and then leave some 15 minutes for questions. So I will go quickly through the various just giving you a brief glimpse of the various possibilities. In this thesaurus, I activated history and validation. So let's make an example. Let's look for Spain. Sorry, the query is a little slow, but the search now, but actually these thesaurus that we have loaded as more more legalization than what they should be, because there are both SKOS-XL and SKOS-core labels. Okay, anyway, but in any case, we're also optimizing the query, for example, by providing triple store specific optimization as it was in VocBench2. So now we are in the Spain concept. Let's suppose that we want to provide a new label. As you see here, there are both SKOS-XL and SKOS-core labels. Actually, there should be only one of them. So I add the new label, for example, for Chinese, because Chinese, if I'm not wrong, it's missing from the descriptions, because obviously there are languages of the EU. So Spain, Sibania, if I'm not wrong. Please, Shufu, correct if I'm wrong. And I added it. Oh, sorry, there is a show more because there are a lot of. I noticed that the interface is a little slowed down when I enlarged the. Probably this is a problem with the browser. Okay, and this is the new label. As you might see, the new label is in green and it's in italic. That's because this label has not yet been validated. Where do we find this information? We find it here. This is very similar to what we had in VocBench2, but the good thing here is that this is completely integrated in the system. In VocBench2, we had completely another parallel framework which need always to be in sync with the data. And the problem is that this sync, for any reason, even a fault could fail, and then it's very difficult to maintain them. Here, there are two advantages. Everything is done through ACID transactions, so that anything goes wrong, it should be not noted on the validation or should not be noted in the action. Everything should be ACID. If the transaction goes well, then you have the action in the validation and the preview in the data. So here you have a description, the commit, the action, the first parameter, and then other parameters. Notice that if you have a larger screen, then we show immediately more parameters. For example, here you have first, second, and then other parameters. When the number of parameters, the number of columns here is not enough to represent all the parameters, you have this dots button. You can click and see all the parameters that have been passed. In this case, a new preferred label has been set for this concept, and this was the label that has been set. So I can decide to accept, validate. It's a little slow. This is strange because usually it takes very few time. Ah, yeah, okay, sorry. And so going back to Spain, let's refresh here the concept. Yeah, and as you see here, it's full in black and no more in italic to tell that this is a stable element in the data set. You can perform some alignment on the fly. Let's see. Okay, by first you have this matrix. It's something quite complicated, but actually not that much once you understand it. And also it's something that only the administrator should manage. This tells that, for example, AGROVOC grants access to this other thesaurus, that is the thesaurus of the Italian Senate, for accessing the data in AGROVOC. This also automatically grants access in read mode to AGROVOC to all the people who have all the users which have access to Teseo without need to be registered for AGROVOC. This is a kind of delegation. So, for example, let's access the thesaurus Teseo, that is the thesaurus of the Italian Senate, and let's look for diritto civile. So here we are, and let's say we want to map these to what? Here only EuroVoc is shown because it's a project which allowed access to the TSEO project only for purpose of reading. So now I say that I want to map to another concept there, and I can decide the concept is scheme to